This is Science 1, which means we come to the 8th and last of the phases of our education. It also indicates to me to be especially attentive, not to bring the course to a conclusion, but to bring the course round so that it could phase back into the beginning of the course without leaving a trace. In an energy phase form cycle, the ecology always reads as a seamlessness, which is not at all the same as a closedness. If you close a circle, this is a form which achieves definition and is objectified in the way in which we would understand something being identified. Whereas a form which has a continuity, a seamless continuity, is not a closed form, but is capable of reverberation. And what our education needs to do in order to keep it from becoming some kind of a doctrinal basis for inculcated values is to keep it seamless rather than closed. So my particular concern in science is to make sure that the science sequence, the 12 lectures plus the interval at the end, are such that they continue to open up so that the lecture following Science 12 will be interval 8, and the lecture following interval 8 will be Nature 1. And in this way, there is a guarantee that none of the material will have been delivered in such a way as to be a hook in any metaphysical or any ideological or even any subconscious unintended way. And we will be free to continue to investigate being ourselves in new dimensions and will not have taken into ourselves some kind of doctrine, some kind of inculcated program that would eventually predispose us to mechanical distributions of human value. So with Science 1, I want to emphasize something that we have become used to in our education, and that is this new phase grows out of the previous phase. And the previous phase is always of a different nature, a different kind. We've seen that in our education there are two types of phases, two kinds. There are phases which are objective, and there are phases which are process. And these two kinds of phases alternate. They have a syncopation to them. In the beginning, the education begins with a process phase, nature. And the objective phase that comes out of that is ritual. Then that is followed by a process phase, myth. And out of that comes an objective phase, symbol. And that is followed in the second year by a phase we call vision. And the objective phase that comes out of that is art. Now, science is an objective phase, and it comes out of a process phase called history. So we need to review for just a moment, not a review of information, but a recursion, a recursive going back and a looping of our experience and our information and our understanding, and to loop that understanding and carry it back into this phase of science, this phase of objectivity. In our outline of the education, There are a couple of pages that are entitled Thoughts on History, pages 33 and 34 of our course outline. The first short paragraph in Thoughts on History reads as follows. Now we're recursively going back and incorporating this into our approach to Science 1. Thoughts on History. With a mythological horizon, one lives within the language forms. The language forms are not contiguous. Here, the meaning is content-oriented and feeling-toned. Psychic energy is a stream of conscious flow, a current mode. And then we saw that this mythic horizon, which has floating in it the images, the mythic images, whose alignments become the myths, and that those mythic lines are capable of a narrative delivery so that one tells myths. But the telling of a myth always has a slightly different course. So a living mythology always is one of delivering variants, much like a musical performance. One has a sonata by Beethoven, but it's different according to different performers. It's the same musical score, but different by different performers. A myth is never told the same way twice. It's always somewhat different, and we'll see later in Science 1 in this lecture why this is real. For now, it's just enough to understand that the mythic horizon of language, where language begins, has this quality of developing an alignment, and this alignment creates the connections that make the language forms, and the language forms are largely narrative lines. They're sometimes even called plot lines. Mythos in Greek means plot, and it means not only plot in terms of like a movie plot or a novel plot, but it also means plot in terms of like an arithmetic plot of the way points connect together to become lines. So that language forms are largely narrative linearities which move by image rollers, and as the narrative line moves over these image rollers, it's a little bit different each time. But largely they collect and make what we could call, in mathematics it's called a bundle. What we would call it today is a general story. It's the story. And there are different ways of telling that story, different narrative lines, but the collection of them, the bundle of the narrative vectors, is the story. So myths tell a story. But that mythic language, which makes these language forms, contains us. We live on that level within those language forms. And their carrying through carries us along with them. So that a tribal mythology guarantees to its people that your life will have meaning, it will make sense, it will have a sequence. Joseph Campbell, in one of his more luminous, humorous moments, said one of the purposes of a mythology is not only to help us understand that we got born and we're here and we develop and there's marriage and there's death and there's all these, but there's also an important part of a mythology that helps you to go, to die, to leave this world. And so a mythology not only has the ingress but the egress. Not only the creation, but the death and transfiguration. So a mythology has this kind of aspect to it. Its narrative flow, moving on image rollers, carries us along with it. Diametrically opposed to this, completely opposite to this, is history. History is completely different. Here, we are the storyteller. The stories are carried along by us. And so conscious language in history does not have, must not have, those mythic qualities. So that the strength of a mythology is in the integrity of its narrative flow. The strength of a history is its differential capacity for variation, according to the storytellers. There must be many different histories, all of which are real, whose bundling is not in an integral fashion, but whose, quote, bundling would be in a differential fashion. Now, if you followed this at all, you can understand that on this basis, there's a very realistic structure to freedom. Freedom is not just a good idea. It's not a philosophic conviction. It is an actuality of the real cosmos. A realistic cosmos only is real to the extent that freedom occurs. Not the freedom of an idea of freedom, no matter how beautiful, no matter how inclusive. Ideas of freedom are always symbolic structures. They are always in the integral mode. They are always mythic language interiorized. And one of the most important things in our education is to understand that this does not carry over into conscious time-space. The integral mode only operates in time-space, or space-time. Can be said either way. But as soon as you introduce consciousness to space-time or time-space and have a five-dimensional conscious time-space, then reality functions in a different way, a whole different mode. It's a different energy mode. Instead of integrating, it differentiates. And as we have seen, one of the most primordial forms that occurs in a differential mode is the spiritual person. Spiritual persons are real, but they are not made by integration. They are made by differentiation. And they are made by differentiation out of a five-dimensional continuum, conscious space-time. When you add time to space, when you take the three dimensions of space and you add a fourth dimension of time, space always curves. Space-time, or time-space, always has as a part of its structure curvature. Whereas conscious space-time not only has curvature, but it has curlicues. And one of the great geniuses of the 20th century was an irreverent mathematician from far Rockaway, New York, who became the local shaman at Caltech for many years, Richard Feynman. And Feynman is the first person to visualize a differential conscious time-space in terms of diagrammatic presentation. They're called Feynman diagrams, and next week we'll take a look at some Feynman diagrams. His diagrams always show a curlicue, so that when we come to one of the texts for Science 1, a little thin book published by Princeton, its title is QED, Quantum Electrodynamics. He has here in chapter 4, the book has 4 chapters. The 4th chapter is entitled Loose Ends. Do you get it? That a differential consciousness understands that you are dealing with loose ends not because it's incomplete, but because your understanding is free. And he has here, figure 77, a little graph of time as a vertical and space as a horizontal. And in naive time-space, the shortest point between two dots is a straight line. But in realistic cosmos, there is no straight line. It never occurs. That's an ideal that is unrealistic. There are all these squiggles, and the more that you become realistic, the more the squiggles happen because of the very nature of electrons, because of the very nature of time-space, the very nature of movement, the very nature of consciousness. And when all of these factors are taken in, and you can understand that one must be very practical. If these are objectively real, they must be computed so that your logic begins to change. And the idea that a straight line is the shortest distance between 2 points is a naive metaphysic and is only operative in a mythic horizon. It even ceases to be operative in terms of a symbolic mind, much less farther down. In fact, we can't just say farther down a narrative line, because the cosmos is not a development farther down anywhere. It is a mature reverberation of the transformed mind that has given up its defining form-making capacity. Now, this is very difficult to appreciate. The statement that I chose to present it is a statement that when Zen masters look at stones and rake sand, they do not humanize them. When Basho was at Roanji looking at the garden, he did not see raked sand and placed stones. Use a little Elizabethan English here. Placed stones and raked sand do not occur to the Zen master looking at Roanji's garden. That is a symbolic way of talking about the composition. There's an artistic mode of participating in that composition, and that is a stronger way of seeing. In his day books, Edward Weston, the great American photographer, said that composition is the strongest way of seeing. But one has to make a differentiation here. A symbolic way of composing, a composition symbolically, de facto takes place in a mind. And though we can't say that the mind is just inside this cranium, more or less, the mind's base, the brain, is inside this cranium. And as long as the mind is analogically correspondent to the brain, then the mind is inside this cranium. It means then that that idea of a straight line between 2 points is visually in this cranium. But in a realistic cosmos, there is no straight line that ever occurs. And this visualization of a straight line in my mental space is a reductive analog, is an idea, is an ideological, metaphysical assumption which just simply is only provisionally there on a mythic level and never is accurate, never is true. And yet, that geometry has a capacity to transform its structure from a representational application, which has a referent back to ritual, to transform from a representation that goes back to ritual to a presentation that goes forward to art. There is a geometricity which emerges not as a ritual confirmation, but as an artistic possibility. Of that geometry, Pythagoras said, this geometry is history. It is very difficult to follow. It's very difficult because we are trained to be stupid. Sorry, I was just like you, trained to be stupid. We are trained that we cannot understand anything unless we identify it by visualizing it, by correlating it with something we can count. And all of this is a great disservice because all of it is only mythically provisional. None of it is realistically true. And yet we have no way to even apprehend this kind of language. We have no way to get traction to begin to explore this. And so we have to work within the old until it becomes an apparent limiting form within which we allow ourselves to transform and then come out. The old symbol of this in Pythagorean archaic Greece was that of the butterfly. The butterfly who is born out of the chrysalis. The chrysalis, which is the end of the life cycle of the caterpillar. But in the chrysalis, the caterpillar dissolves, becomes a bio-slush. And it's not that the caterpillar ever grows wings. It's that the caterpillar transforms and reformulates as something which has wings. And when it comes out of the chrysalis, dries its wings and becomes a butterfly. And the Greek word for that creature is psyche, suke. So that the psyche is quite different from the mind. The mind exists within the being, within us, but the psyche is a spiritually transformed form. And just as the caterpillar can never fly, the butterfly by nature always flies. There is a truth in the realistic cosmos that spiritual beings are always free. Not because they have earned freedom, not because they deserve freedom, not because they demand freedom, but the only way in which they are real is that they are free. Freedom is a realistic dimension of their very existence, their very nature. And yet, even the language itself beggars the understanding because freedom is not something that exists. It's not something that's natural. It's not even a thing. It is a dimensional occurrence that happens supernaturally, above nature. But that supernatural is not above nature so much, it's a differential form in comparison to the integral form of nature. So that vision, art, history, and science are phases of a differential form of the butterfly. And they're related to the phases of the caterpillar, nature, ritual, myth, and symbol. But their relationality only touches at a transformational node. And that transformational node in actual reality is the smallest point possible. The smaller the transformational node, the smaller the point that links these two ecologies together, the more realistic is the cosmos. There is a capacity for men and women to shrink that node to a vanishing point. And that vanishing point, link, makes of these two cycles completely independent pair that operate in a symmetric synergy because of a very weird principle. It's called action at a distance. In late 20th century, mathematical astrophysics has come to understand, because of Richard Feynman's visualization techniques, that there is such a thing as action at a distance. Things do not have to touch to influence one another. And so one comes face to face finally to a very peculiarity, that the truth of the free, realistic cosmos is that love happens because there's no compelling whatsoever. That's why it's fertile. These are some of the points that come out from science. Now let's come back. Let's recursively come back. Let's take all of this whole strategy of approach, this whole characterization of language from an interesting kind of an example. If you look at an advanced mathematical text, this just came out, late 1977, Cambridge University Press, Fourier series and integral transforms. Fourier was a Frenchman during the French Revolution who was universal genius, mathematical genius, and he figured out the way to have a mathematical way of expressing high-level mathematical transformations. He was given medals for it. He was lionized in Parisian society at the time, which wasn't such a good thing because the peasants were taking over and lionized people were being guillotined. But Fourier was one of these fantastic characters. 1997, Fourier's series in integral transforms. We don't have to go into the math. We just have to notice a peculiarity, that the book begins with chapter 0. Whereas, if you look at all mathematical books, especially one on Fourier's series, this is a very classic book, reprinted by Dover because it's so classic it's used worldwide. It came out in 1963, reprinted in 1989. Yeah, it begins with chapter 1, linear spaces. Why would a book on the same mathematical universal series, the Fourier series, one begin with chapter 1, the other begin with chapter 0? Because in between was a monumental discovery. It was written down in several places. I myself was using it as early as the early 1960s. When this book was first published, I was already using zero base. But the first logically presented case for basing computer programming on a zero-base algorithm is from this Dutch genius, Dijkstra, and his book, A Discipline of Programming, published by Prentice Hall, technical books, begins with chapter 0, which is entitled Executional Abstraction. Because if you're really tight in your logic, there's no way you can get any traction whatsoever in reality by beginning with 1. You get an integral bias, which is quite natural, which is ritually very sound, which is mythically quite engaging, and which is symbolically quite formative, and it doesn't go into differential truth at all. It goes into ideational projection very easily, but ideational projection happens to be symmetrical, and you actually cannot tell whether you're regressing or you're progressing. The only way that you can tell the difference between positive and negative numbers is that the zero is quite real, the zero interface. Now, it's true that chapter 0 math books will be so normal in the 21st century and beyond that all of them will have it. But as early as 1933, one finds here a very interesting thing. This also, keeping in the same horizon, this is a book on the Fourier integral, but by a universal genius, Norbert Wiener. He wrote a book called The Human Use of Human Beings. He's the founder of cybernetics. He was teaching at the Massachusetts Institute of Technology, MIT, and this came out, again, Cambridge, 1933. And you'll see in a moment some of the relevance of this. The preface is July 1932. So he's teaching at MIT in the early 30s. And one looks to see, yes, his book begins with chapter 1, but chapter 1 is on page 46. There's a whole chapter which is called Introduction. It doesn't have any numerical designation whatsoever, but it's 46 pages. It is a chapter, and so Wiener subconsciously already understood that you have to begin with 0. He just didn't designate it, whereas the Dutchman Dijkstra was very adamant that we now need to be very conscious that we begin with 0. Because only by having a zero-based algorithm does your mathematics turn out to be real and not just correspondent. There happened to have been a very interesting character studying at MIT in the early 30s. His name was Richard Feynman, amazingly, who was studying around people like Norbert Wiener. And even though he'd come from far Rockaway, New York, from a very dispossessed kind of lower middle class America, Feynman understood something about the mystery of zeros inhabiting a realistic cosmos. And when he grew up, he learned. He looks here like a bongo drummer because he did play bongo drums. This book is entitled, What Do You Care What Other People Think? It's not only a casual statement, what do you care what they think? It is very precise in terms of late 20th century mathematical astrophysics. You cannot go by other people's mental spaces. You can't even go by your own mental space as an arbiter of what is real or what is true. It doesn't mean that your mental spaces or other people's mental spaces are disposable. It doesn't mean that at all. It means that those mental spaces, theirs and yours, are objective on level of symbols. And they are objective. And they do integrate the whole natural ecology. But they also transform. They are capable of transformation. And mental spaces which are not transformed have very bad habit. They tend, with great self-inflated arrogance, to sink back to the mythic and ritual levels, carrying all of their authority and supposed accuracy. And when they come back to those levels, they come back in a regressive way. And this is the way ideologies take over perfectly healthy people without them even understanding that this has been achieved. Feynman was extremely precocious. His lectures on physics occupy 3 big, thick volumes like this that are even boxed as a set. They're sold worldwide. You almost never see the notes, the exercises. I've taken the trouble to go and find all these things. This was published, Edison Wesley Publishing, 1964. Feynman also became a self-taught artist. Very good, very capable of sketching. But what is interesting about Feynman is that we are pairing Feynman with another person, a woman, Mary Leakey. Because we've found that if we take any book by itself, no matter how sophisticated our approach, we will fall into an ideational regression all by itself. And so we do an end run around this entire problematic, this entire bracket of problems is given an exponential quality by the simple process of pairing. Because when you pair, you create a symmetry. And symmetricality is not just that they are two, but symmetry is that they are a pair. A pair is even deeper than the word twinned. In the Tao Te Ching, Lao Tzu says, of the Tao, nothing can be said. But of what can be talked about, pairing is the deepest. It's the deepest structure that's there. So that when you look at a pairedness that's expressed in terms of its conscious differential capacity, the symbol that's used, probably worldwide by now, is the Tai Chi. Even the great physicist Niels Bohr put the Tai Chi on his family crest. A Danish physicist who had the Tai Chi put on his family crest because he's one of the founders of quantum mechanics, because he understood that symbols not only operate integrally as talismans protecting meaning, or amulets protecting meaning, but they have a talismanic capacity to radiate meaning out. And that this protection and this radiation, this keeping into an integral form and this allowing for reverberation of the form out into a field, has actually a language in science. It's called absorption and emission. And you can use the pair of terms, absorption and emission, just as we have used the pair of terms, integration and differentiation. Only it's much better in terms of science, now that we have come to science, to use emission and absorption. When a particle of light, when a photon moves, its movement squeezes radiation out of it. When a particle of light has a dynamic in space-time, part of its dynamic is a reverberation of it is left there in time-space, and that's a radiation, and that can be detected. It's an emission. It shows up as an emission line on a spectrogram. There are also absorption lines that will show up on a spectrogram. If that electron is moving towards us in space-time, it'd be an absorption line. If it's moving away, it'd be a radiation line. It means that in the scientific objectivity, one can not identify so much, but one can come to appreciate the incredible exactness that reality presents. With pairing these books, with pairing Feynman's QED with Mary Leakey's autobiography, Disclosing the Past, we bring together a pair which sets the tone for our whole investigation of science. This pair of books starts us off. Now, we've learned that in the second year of the course, we need to start looking ahead. So not only do we get ourselves this pair of books to start working with, it's not that we're reading these books like texts. It's that we're using these books like a tuning fork. Their pairedness is a hum at a certain pitch, which begins a harmonic which we will be able to not only hear and not only hum, but which will form a basis upon which we could sing. And such celestial choirs have always been the presentation of the divine, always. So the next pair of texts following this tuning fork, Richard Feynman and Mary Leakey, we need to look forward to the next pair, which is a further reverberation. One of them is, in fact, on Niels Bohr. I used to use one of Niels Bohr's books. It's a little too condensed, so we use selections from Niels Bohr's Times by Abraham Pais, the great biographer of Einstein. And paired with Niels Bohr is a book by Murray Gell-Mann, The Quark and the Jaguar, subentitled Adventures in the Simple and the Complex. Now, both Feynman and Gell-Mann were at Caltech. At the same time, Feynman a little earlier. Gell-Mann is mostly in Santa Fe now at the Santa Fe Institute dealing with complexity theory, because the late 20th century has become absolutely mind-boggled by infinite possibilities. It's not that nobody knows, it's that everyone who investigates this now knows that they will never know. And to get traction, to get the courage to live in view of that, takes a butterfly freedom rather than a caterpillar determinedness. It doesn't matter how powerful your ego is and how determined it is, the universe is not there to be crawled over. You may fly in it wherever you wish, but there's nothing there to crawl over. And so you cannot win. You cannot dominate. There is nothing to win. There is nothing to dominate. There are only projections from an ideological mental space that make these playing boards seem partially real. All of that is Maya. None of that is true. None of that is ever possibly true. So we have Feynman and Mary Leakey. Then we have Niels Bohr and Murray Gell-Mann. And the third group will be, the third pair will be molecular biology of the cell. And paired with that is Black Holes and Time Warps by Kip Thorne. Kip Thorne also is at Caltech. So we have a kind of a tribe here. We have the three Caltech professors. We have somebody who's dealing with quantum electrodynamics, someone who's dealing with complexity theory, someone who's dealing with black holes and time warps. So we have this kind of a differential progression that keeps opening up. We want to make sure that this differential that keeps opening up also has its pairedness, which keeps reformulating freedom. So we begin with Mary Leakey. We go to Niels Bohr, and then we come to molecular biology of the cell. The central author of that, there are 6 authors of that. The central author is James D. Watson. And that gives us a link to the very beginning of the course, because we used Watson's book on the DNA, the discovery of DNA, the double helix, way back in nature. So that we end with molecular biology of the cell, and a few weeks later, the 1998 series Nature begins with the double helix. The double helix is about events that happened in the early 1950s. The molecular biology of the cell is third edition, mid-1990s. That in those 40 years, only 40 years, was an emergence from just the barest intuition of a primordial structure and just a few possibilities to a textbook that is about 1,200 pages and growing. 40 years is about the time that Moses kept the refugees in the wilderness. It's only 2 generations, but it's 2 generations in limbo in which a chrysalis has performed its transformation. We're going to take a break, but we need to make this point. We'll bring it back and make it again on tape. What happens in a transformation is that all of the content that was structured before dissolves. Not because you did something wrong, but because you did something right. The content no longer holds its shape because it's transforming. So to panic because the world looks disjointed because everything is dissolving is an unnecessary misreading. It's a cause for celebration rather than depression. The only difficulty is that if you don't emerge and fly, if you don't live your freedom, if you try to go back and be a caterpillar, it's very difficult to do. Because all of the content that once was caterpillar now is slush. And you can go back and be an imagined phantom caterpillar, but in which case you are living in an imagined phantom realm. And phantom mythologies are exactly a good definition of metaphysics. Phantom mythologies. Whereas there is a transformed actuality, which we use the common term these days as cosmos. A cosmology is not at all a metaphysics. A cosmology is a scientific actuality. Yet one of the difficulties that we have is that we are inculcated in an old content where scientific is opposed to the poetic, where the idea of a scientific butterfly is the image of a mechanical creature. All of this is a disservice, and all of this is gratis by an education that was made to service something called the Roman Empire and has nothing whatsoever to do with our lives. The makers of that education have been dead for 2,000 years. The favorite phrase of Thomas Jefferson was, "The world belongs to the living." The basic principle of law is that the world belongs to the living. Let's take a break and we'll come back. Let's come back to, we have a pair of books, and this pair of books is a tuning fork. They're not at all texts. I don't care if you read them or not. I suggest that you struggle to find them and get them and look in them. But your ability to read them is in the future. Right now, the education is an ongoingness, and the most important thing is just to keep it going. It's like doing the asanas, and you just do them. And after a while, the principle of yoga is manifest. It doesn't matter how small the yoga is. It sets up an ordering which reverberates. And if you order any part of an ecology, that order will differentiate and pass through the entire ecology eventually. Will all become ordered, all of it. Because that's the nature of truth, of reality, and we proceed along the same lines. To think that you have to force an understanding prematurely, to use that understanding then to cut out shapes of order, is barbarism. It simply doesn't happen that way. Do you think that children must learn the rules of grammar before they can ask for a cookie? I don't think so. We learn that other way. When Richard Feynman was at MIT, he was a precocious genius. He was absolutely precocious genius. Though he talked like a New York City cab driver, he was incredible in his mental acuity. But he also noticed that one of his favorite writers, a British mathematical physicist named Dirac, Paul Dirac, P-A-M Dirac. And the last sentence in one of Dirac's books, as Feynman recounts, was, "It seems that some essential new physical ideas are needed here." And he got it that physics had come, mathematics had come to some kind of an unknown line. Not so much a line, but an interface where scientific, mathematical, physics knowledge folded under a whole field of unknown. It was like geotectonic plates where one folds under another. And on that interface, you will have earthquakes. It's like the known tectonic plate was having the unknown plate emerge under it. So that instead of the unknown being conquered by the known, it was that the unknown was sliding under. And as one increased one's knowing, there was this odd sense that you also increased the unknowing. This was the state in the 1930s, on the cutting edge of consciousness. It was a disconcerting time. In just a few years before, when Bohr and Schrödinger and Heisenberg were doing their mathematical modeling, I guess for us, several generations, 3-4 generations later, we remember Heisenberg's uncertainty principle, which is that you cannot be certain about two coordinates at the same time, the time and the space. You can know one, but not the other. As you focus on one, the other goes out of focus in terms of certainty. And that what makes it more exacerbated is that the observer participates in that mix. And it turns out that in that whole, what would we call such a complication? In English, we call it a rigmarole. And that whole rigmarole, Feynman was convinced that he was going to have an answer. He was going to have something new. So he developed a whole mathematical theory of action at a distance. And then he went from MIT, he went to Princeton. MIT was already a big professional school, but it's like Caltech. It's not that huge. it's like a technical school. It's a place for engineers, whereas Princeton was a place where the great thinkers were pooling. Einstein, when he came to the United States, went to Princeton, the Institute of Advanced Studies. But while Einstein was going to be the god at Princeton, the resident genius in the physics department was a man named John Wheeler. And sure enough, they made the young, precocious Feynman the teaching assistant to John Wheeler. And Wheeler, looking at Feynman's attempts to make a mathematical theory that dealt with all these mysterious qualities, realized that he had first-class, world-class genius on his hands, but who had very little practical experience at all. Though he was an extremely earthy type of a guy, he didn't have the practical experience. He didn't have the ability to just take the mathematical, theoretical play and see it in terms of simple, everyday things. Wheeler did. Here's how it reads. This is the book, The Beat of a Different Drum, The Life and Science of Richard Feynman. Soon after arriving in Princeton for graduate studies from MIT, Feynman learned what was wrong with his idea that the electron does not act upon itself. The matter was that he had missed the radiation damping force. When you accelerate an electron, it radiates energy, and you have to do extra work to account for that energy. In other words, it loses. It loses not only energy, but angular momentum, which also counts. The extra force against which this work is done is called the force of radiation resistance. The origin of this force, following the work of a Dutch physicist, the Dutch are always somehow involved. The Dutch physicist was Heinrich Antoon Lorentz, famous for the Lorentz transformations. Lorentz identified in those days as the action of the electron upon itself, but the first term of this action of the electron on itself gave a kind of an inertia, that is, a lack of traction. So that the mathematics was peculiar and didn't really work, and there was something wrong, and you couldn't really tell what. Feynman went to John Wheeler, went to his major professor. Look at this. And told him about the ideas he had conceived at MIT and the new difficulty he had encountered in proceeding with his program. Wheeler told him that the answer Feynman got for the problem with the two charges depended upon the charge and the mass of the second charge and would vary inversely as the square of distance between the charges, while the force of radiation resistance depended on none of these things. The force of radiation resistance, being a differential, did not respond at all to integral constraints like space. There's something else operating here. He also pointed out something else that bothered Feynman. If we had a situation with many charges all around the original source at roughly uniform density, and if we added the effect of all the surrounding charges, the inverse, r squared, would be compensated by the r squared in the volume element, and we would get a result proportional to the thickness of the layer, which would go to infinity. That is, one would have an infinite total effect back at the source. So even being a mathematical genius at that time, this early time, this is around the turn of the 1940s, Feynman was boggled by this, but he wouldn't let it go. And there was something in here, the key for him was the word radiation. And wouldn't you just know that the way Mother Nature in her mysteriousness works is that you pick your own freedom. And within months, Feynman was involved with radiation with a capital R. He was involved in the Manhattan Project to build an atomic bomb. Because Feynman was one of these universal geniuses in math. He could do math, which now with supercomputers we can do, but at that time, you had to not only take out your slide rules, but you had to take out your mind, and somebody had to figure it out and crunch those numbers. And Feynman was one of those young mental athletes who could do this. And Oppenheimer needed an ace like this. And so Feynman was the youngest person at Los Alamos. He was the kid. And he was brought in. And as he was brought in, he began to realize there was a sociological reverberation that what they were doing here was they were making an atom bomb. Feynman never forgot that you have to be able to tell the public in very simple mythic images what is going on in a potentially perilous differential cosmos, that they have to get it somehow. So towards what became the end of his life, when Feynman was in charge of investigating the Challenger explosion for the space shuttle, Feynman was the one who took one of those O-rings, a sample O-ring, and put it in a glass of ice water in front of the TV cameras and showed that just simple cold chill made them vulnerable to cracking. And it conveyed in one flash to tens of millions of people what the problem was, what had happened. So Feynman is this kind of a character. And when he went to Los Alamos, and we'll come back to him next week deeper, he underwent a transformation that shows up in QED. Let's work backwards of the first paragraph of each chapter so that you can get it in a nutshell. This is how chapter 4, Loose Ends, begins. I am going to divide this chapter into two parts. First, I'm going to talk about problems associated with the theory of quantum electrodynamics itself, supposing that all there is in the world is electrons and photons, particles of light, particles of electrical matter. Then I will talk about the relation of quantum electrodynamics to the rest of physics. The most shocking characteristic of the theory of QED is the crazy framework of amplitudes, which you might think indicates problems of some sort. However, physicists have been fiddling around with amplitudes for more than 50 years now and have gotten very used to it. And then comes the whole discussion of how there are no straight lines between points. There are curlicues that become more and more complicated as one factors in more and more of the dimensionality of what is real. Let's go back to chapter 3. How does chapter 3 begin? Electrons and their interactions. So we're working back through the book, beginning by beginning. This is the third of 4 lectures on a rather difficult subject, the subject of quantum electrodynamics. And since there are obviously more people here tonight than there were before, some of you haven't heard the other 2 lectures. And we'll find this lecture almost incomprehensible. Those of you who have heard the other 2 lectures will also find this lecture incomprehensible. But you know that that's all right. As I explained in the first lecture, the way we have to describe nature is generally incomprehensible to us by necessity. Let's go back. How does chapter 2 begin? A little archaeology here. Archaeology of the text. Making me temporary potential Foucaultiste. This is the second in a series of lectures about quantum electrodynamics, and since it's clear that none of you were here last time because I told everyone that they weren't going to understand anything, I'll briefly summarize the first lecture. We were talking about light. The first important feature about light is that it appears to be particles. When very weak monochromatic light, light of one color, hits a detector, the detector makes equally loud clicks, less and less often as the light gets dimmer. Okay, let's go back to chapter 1, which is the introduction. He's talking about the woman for whom the lecture series is named. The woman's husband was a friend for 55 years. At this point, he grew up in Far Rockaway with Feynman. And so Feynman is saying, this is a very special event for me to be here, and that I've tried out these lectures in a faraway place called New Zealand, because if I was wrong, no one would hear about it. And that at least the New Zealanders thought it was okay, so here's some New Zealand type truth. What I'd like to talk about is a part of physics that is known, rather than a part that is unknown. People are always asking for the latest developments in the unification of this theory with that theory. They don't give us a chance to tell them anything about one of the theories that we know pretty well. They always want to know things that we don't know. So rather than confound you with a lot of half-cooked, partially analyzed theories, I would like to tell you about a subject that has been thoroughly analyzed. In other words, what's mysterious here is because it is mysterious. That by this time, it was well understood, and it was understood to be very, very peculiar. In fact, the subtitle of the book, QED, The Strange Theory of Light and Matter. It's strange because one comes to understand it, and that it doesn't clear up. It's that you understand that it never clears up, and that's okay. That mental clarity, where you have clear-cut images that refer to things, is itself a sign of illusion. It always indicates that the operative process is mythic. And that's fine for the kind of tribal life that is appropriate to that level. But when you get deep into the mysteries of transformed conscious space-time, they are never visible in the sense that they're never visuable. And to have a clear mind on that level where the visualizations are identifiable and accurate is a sign of delusion. So he writes here, I love this area of physics because it was his playground. And I think it's wonderful. It's called quantum electrodynamics, or QED for short. My main purpose in these lectures is to describe, as accurately as I can, the strange theory of light and matter, or more specifically, the interaction of light and electrons. Photons and electrons. It's going to take a long time to explain all the things I want to. However, there are 4 lectures, so I'm going to take my time and we'll get everything right. And then he goes on about this kind of matter. You can get a copy, you can take a look, and we'll talk more about it next week. But this is not a course in physics, not a course in math. It's not a course in this at all. This is an educational strategy to open up the possibilities wide open. And so we pair with Feynman exactly strategically at this point Mary Leakey. What does she have to do with it? Well, it has everything to do with it. And in our terms, this is extremely formative. Now, one thing about Mary Leakey is that she became the wife of one of the most peculiar people of the century. She became the wife of Louis Leakey, who, as I mentioned last time, discovered when he was away from his native Africa, studying in England, he discovered that he did not dream in English, but that he dreamed in Kikuyu. As a boy born in Africa, he grew up playing with Kikuyu tribesmen boys, and he never realized that he was anything other than just a human being. But he was a Kikuyu human being, and his native first language is Kikuyu, not English. And so his autobiography has this wonderful title. He called himself a white African. The quotation at the very beginning is a quotation from one of the elders of the Kikuyu tribe. "We call him the black man with a white face," said Chief Kanange on a recent visit to England, "because he is more of an African than a European, and we regard him as one of ourselves." In fact, he was always a tribal member. He was an elder. And whenever there were any decisions about the land, about the herds, about the people, he was included as an elder, as a tribal member. He belonged. He discovered that being a tribal Kikuyu man, that when he went back to Africa from Europe, when he had discovered this phenomenal truth about himself, when he went back, he carried with him the feeling tone that he never was at home in England. Let me put this more simply. The English landscape never talked to him in personal terms. But when he went back to Africa, the African landscape included him as a part of its reality. He was not only at home in Africa, he not only belonged there, but the landscape talked to him. Because when you're at home in a landscape on that level, you hear those voices. I remember the first time of lying in a shallow stream in the western slopes of the Sierra Nevada. I was about 19 years old. And I was my first experience of hiking in moonlight. And I went out about 7-8 miles, not all that far. And I was lying, because I got overheated from trying to push too much. And I was lying in this shallow stream. And I can remember hearing the voices. It was like a background conversation that many people were having with kind of a hushed intensity. And I couldn't quite follow what they were saying, but I could hear that it was a population of people talking in very measured, hushed, intense tones. And I thought there must be some camp or some people. I couldn't see any glow of a campfire. And got up from that stream and looked around. Then it was that I could hear that actually what I had heard was the water running over a stretch where there were loose stones about the size of a fist, and that the rocking of those stones in the current made that sound that in my state of being with the land, of being there, in that particular way was indistinguishable from human speech, and learned over several years to pay attention to that and to hear that language, to hear how that was. So that maybe 4 years later I could tell realities about the forest which the land said. For instance, the land will tell you when the change of season is there. The big change of season in the Western Sierra is the onslaught of autumn, which is the first knell of winter. And the whole landscape says autumn in such a way that the feeling tone of it is a somber nostalgia that penetrates. That days in the sun are over and you better get set. That kind of a thing. But not in words, but in feeling tones. What's difficult is that that language of the land is a mythic language. It's a mythic language. And does not occur. You can't hear those natural voices in history. You can't hear them. So that if you want to return back and you want to hear the voice of the land, you have to be able to take yourself out of history. And you have to be able to do that without regressing. Because the automatic way in which you would be able to return to a mythic level is through a regression from history, from consciousness. And this is very difficult. Because if you do, history is such a difficult process to win access to. The initiation into history is on a much higher level than initiation into myth. Becoming participant in the land almost as a given of nature. It's almost like a feminine gift of life to a being. One feels kinship with the animals and the plants because everyone receives this kinship. But it's a kinship on the integral level. History has a kinship on differential level which is totally different. And if you look for feeling tones, there are no feeling tones whatsoever. They're in fact abstracted so that one, in searching for feeling tones, finds only shorted out, neutered blankness. If one were still to judge what is real and what is good on that level, one would shy away from this as if it were death. One would look upon conscious differential cycle as a death. Don't go there at all. The only people who go there are magicians and the injured, the sick, the dead, the crazy, the peculiar, the weird. They're the only people who go there. And so for tens of thousands, if not hundreds of thousands, if not millions of years, the realm of conscious differentiation, if approached at all, was a taboo ground. Only under extreme duress and special conditions of illness or death would anybody venture into that realm at all. It's a netherworld, it's other world, it's a forbidden world. And it takes a long time of exploring that realm, that differential realm, that one comes to the ocean of history, even much less comes to its shores, much less is able to see that this is something that has to be navigated. And that science is on the further side from that. So that science is very peculiar. It's the most perilous of all objective states that are real. And in order to make it palatable at all, the natural tendency is to sugarcoat it with the mind, to give it a frosting of symbols. And it's completely natural that we do this. Everyone does this. But it's those symbols that are the last vestige of delusion. They're the last sheen that causes us not to see what it is, but to only see the glint of what we suppose it must be. And so science is a differential objectivity that requires a very strong discipline to deal with. And the discipline is one that needs to be engendered, not with a mind of throwing nature away, or throwing myth away, or throwing ritual away at all, or even letting symbols go, but that all of this becomes an integral, as if it were a tectonic plate that has temporarily gone subconscious. It's still there, it's still operative, still true. One can still access it. But one doesn't access it in one square of attention. What you are attending to is the vision, the art, the history, the science. That square of attention is the conscious square of attention, conscious differentiation. If one has come to that through that hard-won transformation, it's possible then to go back and forth through a transform without losing any reality. Whereas the old, limited, superstitious supposition is that once you are transformed, you can never go back. And that's not true at all. It's only true if that were a forced, sudden, catastrophic, accidental transformation that you weren't prepared for at all, in which case you most likely could not go back. But if you come to it through an educational process, and that transformation, that transform, is a part of the way in which that node operates in a complete double ecology, one can go back and forth easier than taking city bus. There's no problem whatsoever. One can go back and sit with the elders and dance to a marriage ceremony with absolutely no forgivings that this is not scientific, because what one is doing here has nothing to do with science. It has to do with confirming the synergy of two beings in terms of the life process, the food, the land, the children, the life. Leakey was one of those peculiar people who was able to go in the complete ecology of this cycle. He was able to be tribal, elder in Africa, absolutely not European. Absolutely not. And yet he could take that Kikuyu beingness in the land and listen to the landscape in such a way that he could recognize the difference between a little bit of rock and a little bit of bone from some pre-hominid being who had lived millions and millions of years before, and who had left a fragment so weathered and worn that it was not distinguishable from a stone in any normal way. Mary Leakey was able to be so close to Louis Leakey that though she was English, an English woman, she slowly Africanized herself so that she became not only preferably at home in Africa, she lost her Europeanness. She lost her Englishness, and she also became African. She became Kikuyu. She learned to see in such a way. And so it's not because it simply was so difficult to find the first fragment that it took them almost 30 years of looking. They went out together to look for something that they could not find for 30 years. And they only found it in 1959 in the summer. They found it not because Louis Leakey was there to see it, but because Mary Leakey had learned so well from her husband that she had become Africanized enough that the landscape spoke to her. And that this little fragment of petrified jaw, which looked like, just like stone, said to her, a living man-like being, was about several million years old. She writes it this way. At that point in July 1959, we had what seemed to be the first stroke of luck for some while. One of her African sidekicks was named Heslan Mukiri. Heslan Mukiri, inspecting bed number 1 sites on foot, some way down to the east end of the main gorge, the old Duvai Gorge that runs off a great, huge, archaic, ancient meteor crater, came to this particular site, the MK site, a korongo named after Donald McInnes, who had found it during the 1931 exposition. There, Heslan found a hominid tooth in a block of limestone, and after the matrix had been removed, it was found to be still in place in a fragment of lower jaw. And about this time, in a very peculiar way, Louis Leakey became very ill. As soon as this came in, it was like this shamanic type illness hit him, like a flu, but he was laid up, and he himself could not go out to the beds to confirm or to find or anything, so Mary had to go. Louis got an attack of flu and retired to bed, and so it came about that on the morning of the 17th of July, 1959, I went out by myself with my 2 Dalmatians, Sally and Victoria. She always traveled with Dalmatian dogs. Eventually she had about 8 or 9 of them, and they were her gang. So she would have her African co-workers and her Dalmatians and her little boys. And she'd be out there alone on the vastness of the African plains and veldt for decades. And this was her realm, her world. What's peculiar is that Mary Leakey was able to not only get this from her husband, this quality, but she was able to pass it on to her children, especially her oldest son, Richard, who refused to be interested. He didn't want to be interested, didn't want to know anything about it, and tried, as a growing up boy, not to pay any attention to it, and that was wonderful because he never learned the scientific approach. Primarily, he learned the African approach, that you just live there, but you live on such a deep level that you're a part of the landscape. Because it was later that Richard Leakey, from an airplane, would spot some terrain in one of the great rift sections, and the terrain said to him, "Look here. Come back here. It's here." And all the great advances of the last 25 years have come from the developments out of that site. Whereas his father had done the same thing in the early 1930s. He was on a boat trip across Lake Victoria. And because of some kind of storms and currents, they came very close to an island called Rusinga, out there in Lake Victoria, and the land said to him the same thing it said to his son 50 years later. It said, "Come and look here. that this is the spot. And Leakey remembers looking through field glasses at the geological strata on this island and realizing that this was an outcropping that was the same as was there in Olduvai Gorge inland from the lake shore. But in between Lewis and Richard Leakey, Mary Leakey, the wife, the mother, was the one who at this particular magical moment, because it's the first time that any evidence whatsoever that man was older than what? Lewis Leakey's first book is called Adam's Ancestors. And he says right in the beginning here, not chapter 0, but chapter 1, it is not so very long ago. He wrote this in the 1930s. In other words, this was being written at the same time that the developments in physics were happening. So the 1930s are some formative interface in history. All this at the same time. Leakey writes, chapter 1, the search for man's ancestors. It is not so very long ago, a matter of 100 years only, that people still accepted the opinion of Bishop Ussher, an Irish clergyman, that man was created in 4004 BC and that Adam was the first representative of humanity on earth. That man is no older than less than 6,000 years, tops. The wonderful film Inherit the Wind is about the Scopes trial where Clarence Darrow defends this young Tennessee high school teacher who teaches that evolution is a possibility, and this was in 1926. And he was prosecuted for teaching something that was against religion and therefore not true, because the defending lawyer opposite Clarence Darrow was William Jennings Bryan, and he held that the Bible says man was created by God, and Adam was the first man, and when you add up the generations in the Bible, it comes out to 4004 BC, and that's it. That was 1926 in U.S. courts. It was a verdict by a jury. This is less than 10 years later. So Leakey is going against an enormous tide of conviction that was there for untold centuries, perhaps millennia. His contention could not be proved until July 17th, 1959, when his wife came back to camp because she had seen something. The land had shown her a little tiny fragment. Then she went over with trembling hands and brushed this little fragment out and came back, the Jeep with the Dalmatians' tongues hanging out, racing into camp, and Lewis, sensing something, runs out of his bed, flu and all, grabs the piece and looks at it, and they looked at each other and they realized they had found it. It was the first physical proof that not only man is more than 6,000 years old, but that he is millions of years old. More next week.